Hello, I'm Martine Davis, and I'm a certified building biologist in Madison, Wisconsin. I have inspected approximately 3,000 homes for indoor air quality and mold since 2000. People are more and more aware that environmental factors affect health, so these types of inspections are getting very popular. The reason for an inspection varies. It could be because somebody is buying a house, it could be because they discovered mold in the home, or they have odors that are they don't know the reason for the odor, or it could be because some of the occupants or all of the occupants feel sick in the home, and they notice that when they go away they feel better and they come back in the home and they feel sick again. When we analyze air quality, there are three components that we look at: particulates, gases, and volatiles. Particulates are things like dander, soot, pretty much anything that's in dust, like mold, would be a particulate. Gases would be things like sewer gas, natural gas, and volatiles would be things like benzene or toluene emitted from a garage or from storing gasoline in a garage, or semi-volatiles, which would be pesticides. Air quality problems can also be caused by improvements to the home. For example, a new addition, a new kitchen, remodeling a home, adding a crawl space to the new addition that might cause some mold to enter the home. Sometimes perimeter drains are installed in the basement for water seepage, and it can cause too much humidity and mold. Heat recovery ventilators can cause mold issues. The process that we go through is to first research the property before we even go to the property. So we'll look at the county or city assessor site, maybe look on Zillow, and get some information about this property. Does it have a basement or a crawl space? Is the garage attached, or is the garage located underneath a bedroom? What's the year of construction? What type of heating is in the home? Then we go to the property and interview the client, find out what their concerns are, their reason for the testing. What are some of the symptoms the occupants suffer from? Do they have special concerns with allergies or asthma? Once we have this information, then we conduct the assessment with air quality instruments, and we collect air samples and surface samples. These samples may be analyzed by a chemistry lab or microbiology lab. Some of the samples will be analyzed actually by the equipment itself, and we'll get the results right there on site. Once all the information is back from the lab, we analyze everything, interpret the lab results, and then we develop a solution, a plan of action, and some recommendations for the client, which we put into a final report. So now let's see how we conduct an air quality assessment on location. So we are here in the library at InterNACHI headquarters, and we're going to give you a brief overview of some of these air quality instruments that we use out in the field and what they are used to measure and how they work. So one of the components of air quality is carbon dioxide, and we measure that real time with this type of meter. This particular meter gives us carbon dioxide and also the temperature and relative humidity. So relative humidity is important because mold starts to grow at about 58 to 60% relative humidity. So particularly in basements, we want to make sure that the basement has proper dehumidification so that it's not conducive to mold growth. The carbon dioxide measurement is a surrogate for the ventilation rate. So it actually is a measurement that tells us if there's enough fresh air in the home. And fresh air and ventilation are very important to air quality. It's important to people's comfort. When carbon dioxide gets too high, people feel lethargic, they feel fatigued. And so we wanted to see that carbon dioxide at least no more than 1,000 parts per million. Another thing that we test for is particles in the air. So we can use a particle counter. This particular meter I would use in pretty much in all the rooms that are occupied frequently. So that would be the bedrooms, the family room, possibly the kitchen. And this particle counter will measure the dust in the air and gives us a number of particles for different sizes. This particular one is a 6-channel particle counter. So it will give me different size of particles and how many of them are currently in the air. And of course, we want this lowest number possible. We don't want to be breathing a lot of particulates. And what we do as far as what number is correct is we compared it to outdoors. Some cities have very high particle counts outdoors, so we would expect the particle counts indoors to be higher. And this is where maybe the customer is going to need to add filtration. Filtration, a good filter on the furnace, or maybe add an air purifier. So we just run this for a few seconds. It actually is intaking air here and then giving us a number on the screen, giving us some numbers, and we will compare that to the outdoors to see if the filtration in the home is adequate. So often what we want to test in a home is either a single compound such as benzene. For example, if the client has a garage that's located directly underneath a bedroom, it's possible that benzene fumes, car exhaust, or gasoline fumes from the lawnmower could make its way up to the bedroom through the stack effect. So if we want to find out if there's a problem with benzene, we can use several different tools. One is a lab test. The lab provides this tube that fits into this pump. It's very easy to operate. The tube just goes into the pump and it's run for 20 minutes. And after 20 minutes, the tube is put back into the carrying tube and sent to the lab. And within a few days, we get a lab report that tells us how much benzene we may have. It also, lab results usually will indicate other VOCs that may be in the home. So this is one way to do it. Another way is to do it with a real-time piece of equipment that's going to give me a real-time reading right there on site. And the way these work is they have a chip for each chemical that you want to test. So if I wanted to test for benzene, I would go to my benzene chip and I insert that in the machine. The machine recognizes the chip, tells me, yes, you have a benzene chip. It will measure the air, and then within a few minutes, I'm going to get a reading on this machine that's going to tell me exactly the level of benzene in this room. There are definitely, for benzene, because it's a carcinogen, there are some guidelines, government guidelines, and we know what a safe level is. So this gives me an actual number right away. This machine is for total VOCs, and this is more like a Ghostbuster type of meter. We walk around the entire house with this meter while it's running, and it gives us a real-time readout of what the total VOC level is. This is called a VOC meter. It uses PID technology. And what's good about this is for demonstration purposes, it's really interesting for the customer to see as we go from room to room, which room has the potential to be more toxic from an air quality standpoint, especially to demonstrate for garages as we get close to the gasoline containers. They can see that the VOC level goes way up when we get near these, because all these containers actually leak fumes. Even though we may not smell them, it's still happening. Let's test some of these air quality instruments in the House of Horrors. So we're here at the House of Horrors. Let's go check the air quality in some of these rooms. Okay, so we're in the kitchen, and we're going to be looking at air quality factors in the kitchen. Actually, in a kitchen, there are several things that can cause bad air quality. One thing is the cooking exhaust, and we want to make sure that the cooking exhausts are exhausting to the outdoors. And also we want to mention to the homeowner how important it is to actually turn on the fan when they're cooking. A lot of times it makes noise, so they don't like to use it, so they don't. I had one customer in a house that called me because the child had an asthma attack practically every night around 5, 6 o'clock at night, and they couldn't figure out what was the trigger for this asthma attack. And it turns out that it was the aerosol, the cooking aerosols that were produced every time that they cooked around that time of day, and the exhaust actually was not being used. So that was a simple fix to that. Another thing that we check in the kitchen is we check for moisture, of course, because we have a dishwasher, we may have a refrigerator with an ice maker line, and there may be leaks that the homeowner doesn't know about, because depending on the type of flooring, it might not be visible to the naked eye that there's actually water seepage. So I'll go around the appliances that may leak, and then I will use my moisture meter and then just check the moisture all along around the refrigerator, the sink, and the dishwasher. The other thing that can happen from an air quality standpoint in a kitchen is if at any point in time there was a leak in the dishwasher leaked, or there was a leak underneath the sink, it's quite possible that water made its way behind the toe kick. And as you can see here, you cannot actually access this area underneath the base of the cabinet. It's completely hidden and sealed. So if the homeowner tells me that at some point in time there was a leak, or if I see signs of water leakage, I see water stains, then I'll take an air sample so that I can see if there might be some mold in that area underneath the base cabinet. And so the way I do that is I'm going to use an air sampler, and I'm going to use a simple air sampling cassette, but I'm going to have an additional tube that I'm going to add, and it's going to allow me to get into that hole there where the pipe goes. And I'm going to go ahead and insert this tube in the hole there. So that's going to give me access to the area behind the toe kick that we cannot see. I'm going to tap a little bit to loosen up the dust because the mold is in the dust, and if there's mold in there, I want to capture it. And then I'm going to take a 5-minute air sample. Once the 5 minutes is over, I'm going to take this off and send that to the lab and get an answer as to whether we need to open this cabinet up or not. The other thing that I do in a kitchen is I'm going to use a gas analyzer if there's a gas stove. And I'm going to ask the homeowner to pull out the gas stove. I don't want to take responsibility for pulling that out because that could do damage to the floor. And then once they pull that out, I'm going to check the gas pipes and the valve. And actually, I find that a lot of gas stoves, especially the older ones, very often have gas leaks in the back. So it's important to try to pull that out if possible. So we're in the utility room now. And from an air quality standpoint, the utility room is crucial. This is an area we can have gas leaks, we can have mold, and there are a lot of things that can go wrong in the utility room. These things will affect the upper floors and the occupants upstairs. So one thing that we check first in the utility room is going to be for gas leaks. If we have gas appliances, usually we have a gas furnace, possibly a gas water heater. So I'm going to scan these pipes with the gas analyzer, and I'm going to go over all the joints slowly and listening for an audible alarm that's going to tell me that there might be an issue or might be a gas leak. If I have access to the front panel, I will go ahead and check the gas pipe inside the furnace. And also I want to check the valve. A lot of these old water heaters have defective valves, and so we may not get gas leaks on the pipes, but we may get a gas leak on the valve. The next thing I'm going to check is going to be for carbon monoxide. And for carbon monoxide, we're going to look at the exhaust from this water heater. We see here that there's a descending incline, which is against code, and it's also very dangerous because we can have backdrafting. There's a chance that we can get carbon monoxide coming back because of the incline. There's also a bad connection up here that's been fixed with duct tape. High probability that I'm going to get carbon monoxide reading in that joint there. And then finally, the hood is not seated properly. So what I would do then is I would turn the water heater on, and I would turn it on high so that it would kick it in, and then I would put my carbon monoxide analyzer right there, and then wait for it to kick on, and then see what the readout says. If there's high carbon monoxide, obviously this needs to be shut down and it needs to be serviced immediately since carbon monoxide is so dangerous. The next item is going to be the interior of the furnace. Some furnaces, we have the A coil accessible. If the humidifier is installed and it's in front of the A coil, I'm able to take the water panel off and get a visual on the A coil. I look for things like dust or mold, debris, and the coil should be clear like this. If it's not, then I'm going to go ahead and swab it. And I'm going to swab the surface lightly with a swab, and then we're going to get this sent to the lab and analyzed to see if we may have some microbial growth. Why is that important? Well, for obvious reason, if we have mold on the coil, every time the furnace kicks on, some of this mold and the mold byproducts is going to be going into the furnace, into the supply, and it's going to be supplied upstairs to the occupants. The other thing that we're worried about is the drip pan that's underneath this A coil. The drip pan can grow slime because a lot of times the A coil will drip, and then we have slime or mold growing in there. And I've had several clients that actually have had children that would be sick because of mold growing in this drip pan. This can be cleaned by an HVAC contractor. We can also do the same thing, swab that drip pan, send it to a lab, and see if we have a microbial problem. And then finally, I'm going to check for mold. I'm going to check behind the appliances that may have leaked in the past, such as the washer, the water heater. I'm going to check behind there, check the drywall. A lot of times there's a little bit of mold there. It could be some very toxic mold, and the homeowner is not going to be looking in that spot. They're not in the habit of going into their utility room and looking behind the water heater for mold. So we check all of these areas in the utility room if there's drywall in particular. So one thing that we're concerned about from an air quality standpoint, and it's not mentioned very often, but it's really important, it's fiberglass. These tiny fiberglass particles, if they get in the air, they can get in people's sinuses, they can cause very minute cuts. Then those cuts can get infected, which results in chronic sinusitis. So it's important to check for loose fiberglass anywhere. And one of the major places where we find fiberglass is going to be inside the furnace. A lot of these furnaces are lined with fiberglass of some kind, whether it's for sound or any other purpose. And this particular one that we're looking at here does have the foil cover, and that's what we want to see. We want the fiberglass to be enclosed and sealed, and so here it's behind the foil, and as long as this would be actually sealed to the edges, then no fiberglass could escape and get entrained into the system. One thing that I like to do if I see that the interior of the furnace may have something that looks possibly like mold, if I'm not sure, then I'll go ahead and swab that surface like we did on the coil. The same type of swab, send that to a lab, and double check that this does not have microbial growth, which could affect the health of the occupants. Obviously, every time the furnace runs, whatever's in the furnace gets distributed through the supply vents. When it comes to fireplaces, we have seen a lot of defective valves in these types of fireplaces, the gas fireplaces. So in the air quality assessment, we always check these gas pipes and the gas valves that are in the fireplace. And if you look in there, you can see the joints, you can see the brass there, you can check the valve, and then you can check the other. There's usually going to be 3 places to check in the fireplace. And what happens with these is we can have large amounts of gas coming out of the fireplace. The whole family is usually in the living room, using the living room on a regular basis, and they do not smell the gas. And this can cause upper respiratory issues, pulmonary issues. It's important to catch these because it affects health.